Good day, everybody. How are you all? This is Dr. Nandi. Today, we are going to discuss a problem where we are going to use a normal approximation to a binomial distribution. So we are going to use a continuous probability distribution when the problem is for a discrete probability distribution, which is the binomial distribution. But there are certain instances where we can use this approximation, as I will explain to you soon. Says the mayor of a small town estimates that 35% of the residents in town favored the construction of a municipal parking lot. If there are 350 people at a town meeting, find the probability that at least 100 favored the construction of the parking lot. Based on your answer, is it likely that 100 or more people would favor the parking lot? So solution. First, let's check n times p. So n here is a number of trials is 350 people who attend the meeting. P, the probability of success is 0.35. Okay. And Q, probability of failure is 1 minus P is 1 minus 0.35 is 0.65. Let's calculate number of successes, which is n times p, which is 350 multiplied by 0.35. And that is equal to 350 multiplied by 0.35 is 122.5. And number of failures is equal to n times q is equal to 350 multiplied by 0.65 is equal to 350 multiplied by 0.65 is 227.5. Okay. Both n times p and n times q are at least 5. Okay. Therefore, we can use normal distribution for this binomial distribution problem. Why this is binomial distribution? Again, there are two outcomes. Either they support the construction of a municipal parking lot or they do not support. So there are two outcomes. Either you support the parking lot or you do not support the parking lot. Therefore, we can use the normal distribution for this binomial distribution problem with a, so let me erase that. With a correction for continuity. for continuity. Okay, so I'll create some space here. So the question, before I move it up, is read the question. The question is find the probability that at least 100 favor the construction of a parking lot. 100 favor the construction of a parking lot. So to find at least 100 means 100 is the lowest number. To find the probability of X greater equal to 100. Okay. And what will be the correction factor for that? That will be with the correction factor. With the correction factor, okay, for continuity, P X greater equal to 100 is actually P X greater than 100 minus 0.5. Okay, so that will be equal to P X greater than 99.5. Okay, now our mean mu is equal to N times P is equal to 350 times 0.35. Okay, which is 122.5. Variance sigma square is N times P times Q. So that is Q. So it will be 350 multiplied by 0.35 multiplied by 0.65. And that will be equal to 350 times 0.35 times 0.65 equal to 79.625. So if I create some more space, so standard deviation is equal to square root of variance, and that will be equal to square root of 79.625 equal to 8.92. Okay, again creating some more space. So if I now draw the normal distribution, you will see what's going on. So I draw a bell-shaped curve. This is a normal distribution. My mean is 122.5, where the peak of the relative frequency is the highest. So mu equal to 122.5. Standard deviation is equal to 8.92. And I want to find the probability of X. 99.5 is less than the mean, 122.5. So 99.5 will be somewhere over here. And I want, this is your 99.5. And I want to find this area. Remember, this curve stretches to positive infinity or a very large number on the right hand side, which in the calculator we will approximate by 1 exponent 99. Okay, so we have to find probability of X greater than 99.5. Okay, so use TI-84. Second key, then verse key, then scroll down to normal CDF and hit enter when you reach normal CDF. So second verse, VARS, is in the third row of the calculator. Then select normal CDF and hit enter. Okay. The first thing it asks for is the lower. Okay. My lower is 99.5. I'm starting from 99.5. My upper is 1E99. How do I do that? I type 1, then second button, then comma button, which is on top of the 7 button. That will give me the small capital E, and then I will type 99. 1E99 means 1 followed by 99 zeros, followed by 99 zeros, or 1 exponent 99. Okay, so upper is 1, then second button, then comma button, which is on top of the 7 button. That gives me the small capital E, then 99. 1 followed by 99 zeros is a very large number on the right-hand side. My mean is 122.5. So type in mu is 122.5. My sigma, type in, is 8.92. Okay, let's create some more space. And then below mu and sigma is paste. So put the cursor on paste. Put the cursor on paste. That is the black rectangle on paste, and hit enter and enter. Whenever the cursor sits on paste, we have to hit enter twice. Enter and enter. Maybe I should write this clearly. Enter and enter. Okay. So enter and enter. And the answer is probability of X greater than 99.5 is 0.995. Okay. Did we do it correctly? We can check with the binomial distribution. Okay. We can check our calculation with binomial, with using actual binomial distribution. Actual binomial distribution information. Okay. So we are required to find out P X greater equal to 100. Now we will use the law of complements of probability. Okay, X greater equal to 100. The opposite event is X less than 99. Less equal to 99 actually. So law of complement of probability, law of probability of complements event. Use law of probability of complement events. Remember, complement is the opposite events. So in this case, complement meant. So let me use that. Complement event. Okay. So probability of X greater equal to 100 is 1 minus probability of complement event, which is X less equal to 99. Okay. Because X less equal to 99 is complement or opposite of X greater equal to 100. Okay. And that will be use TI-84 calculator. Okay, so I'll create some more space here. So this will be 1 minus, we'll press the second key, then the verse key on the third row, VARS. Then we will scroll down to binomial CDF. Okay, so 1 minus second verse, scroll down to binomial CDF and hit enter. Okay, then enter after this. Okay, and enter the following information. Trials, that means N, is 350. Probability of success, P, is 0.35. This is probability of success. Probability of success. Okay, 0.35. And we want to add up the probability from 0 to 99. So X indicates the last value from 0 up to that number which we want to add, which is 99. So type in 99 for X. And paste, put the cursor on paste. And hit enter and enter twice. Okay. Enter and enter. Okay. Enter and enter. And lo and behold, the answer is same as before. So let me get some space here. Here also we get probability of X greater or equal to 100 using binomial distribution. Using binomial distribution. Is equal to 0.995, which is the same answer as using the normal approximation. Which proves that the normal approximation that we use, the continuity correction factor that we used, is appropriate. Now there was another question which I want to answer, which was part B actually in the question. So we'll go down to the question or go up to the question. Based on your answer, is it likely that 100 or more people would favor the parking lot? Since your probability answer for X greater or equal to 100 is 0.995, part B. Since probability of X greater or equal to 100 is 0.995, which is greater than 0.5. Remember, we get a majority when we are greater than, probability is greater than 0.5. It is clear that more than 100 people will favor the parking lot. Favor the parking lot. So I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. If you like this video, please share with your friends. Please, you and your friends, subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day. See you next time.